Hello guys, welcome to another tutorial. Today we're going to be creating a guest book contract in Rust, and we're also going to be talking a bit more about serialization using Borscht serializer and how Near serializes data to be stored on the blockchain. Okay, so let's start by creating our project. So I'm already inside the Near directory where we have all of our tutorials. Switch into the contracts directory first. And npx create Near app, and then latest guest book contract Rust. Front end we're going to have none, and the tests are going to be in Rust. For now we're not going to be writing tests, but this flag is required by this command. Let's run this thing. The contract has been created. List. Let's change into the guest book directory and open our Visual Studio Code. There are a few things that I'm going to have to do in the cargo toml. I'm going to switch it from hello Near to guest book. Save it. And also in the package JSON here, I'm going to do a find hello Near. I'm going to replace it with guest book. And we're good. Now I can finally open my Rust file, librs, and I'm actually going to delete this whole thing because we are going to be creating a brand new contract. I'm going to copy the very top. Now, as you can see, I included a disclaimer here because all the code is provided as is, and it has no guarantees. So if someone messes something up and their smart contract ends up rug pulling a bunch of people, don't come to me, okay? So anyway, let's start importing all of our libraries that we need. I'm going to copy and paste these things. So over here we're importing the Borscht serialization, deserialization, some of the Near SDK items here. Near SDK collections vector. Actually, we don't need the lookup map in this case. We just need the vector. And this is the comparison minimum because we will need to compare two integers and get the minimum of the two. Now I'm going to set a constant here. It's going to be called message limit. It's going to be a U64, and we're going to set it to 10. Now I'm going to define our struct, so Near bindgen, and we're going to set the serialization derived traits. I need a Borscht, deserialize, Borscht serialize. Now I need to set up pub struct. And it's going to be called contract. And now I'm going to set messages. And it's going to be vector of string types. Okay. And we're done here. Now I'm going to implement default trait. For contract. Set the function default. Okay. We need to do a self here. And messages is going to be vector new. Vector 2 colons new. And I'm going to set the prefix that is going to be taken up inside the blockchain serialization for us. So it seems that we have up to 26 prefixes we can use, characters from A to Z. Possibly we can use other characters as well, although I didn't try that yet. So I'm certain that we can use the 26 English alphabet characters. The rest I will post in the update if I find out if you can use. So in our case, let's just do, because it's a vector, I'll just set it to our prefix to v to symbolize vector, and that's it for our default. Next, we're going to implement our methods. So IMPL contract, and we're going to have a few methods here. Pub, one is going to be add message. I'm just going to leave it as is, and the second one is going to be, oops, I need to do pub fn because it's a function, and the other one is going to be pub fn, and this is going to be get messages. Now add message, we need to pass a mutable self, and the value that we're going to be posting into the blockchain. So I'm going to put a txt, and it's going to be of string type. The get messages does not take any arguments except for just reference to self. Okay, so let's start with add message. Add message is fairly straightforward. We just need to do self dot messages dot push. Where's the, do we have push here? Yeah, push, and then we need to put the string in there. So it's going to be a reference to the txt, and that's that. The next one, some strange complaining going on here. I wonder why. Ah, a typo. Okay. All right, now get message is a bit more complicated. So we need to set a few variables that we're going to use. So set num messages equals min. This is where we use the minimum between the two values. One is going to be message limit, and the other one is going to be self messages dot len. This is where the reason why we had to set the message dot limit to the unsigned 64-bit integer, because this thing right here, the messages.len, returns a u64 as well. So we can only do comparison between two identical types. Otherwise we have to do casting, and that is error prone. So I mean, no need to add extra complexity right now. Okay, so now we did the comparison between these two. Let's move on to the next part. We need also to get a start index. So let start index. This is going to be self messages length minus number of messages. I'm going to actually put a log here just so that we can kind of see where this is going when we're submitting the smart contracts. And I'm going to set one more vector, only this one's going to be a regular Rust vector. So let mutable result, and this is going to be equal to vec, and it's going to be empty right now. So for I in 0 to num messages, we're going to do result dot push, and then self dot messages dot get, and we're going to get I plus start index. Then we're going to unwrap this thing. And now that we have results, we're going to return third JSON, and over here we do toString because we need to return a string. Actually, speaking of this, I actually need to set this return to string. So we're doing asserted JSON to string, and then over here we set the what I'm trying to convert to string. It's going to be a reference to a result, and then I'm going to do an unwrap this as well. Going to save this. Results. Okay, so at this point our contract is done. So what we're doing in the add message, we're simply pushing a new text message to the messages vector here. But in the get messages, we're actually doing some calculations to get how many messages we're going to return and from which index to which index. Then we're creating a vector of results of the messages which we're going to return, and then we are doing conversion of these of this vector to JSON string and returning it. Let's try compiling this contract and see if it actually works. Gonna have to change into contract. Going to run rust up target add wasm unknown, what wasm 32 unknown. And now let's try to do a cargo build. Okay, the contract is compiled. Let's check the size of our compiled contract. Seems to only be 86 bytes right now. Okay, that's pretty small. I wonder why it is so small. In any case, let's create an account in which we're going to store this. I'm going to go near create account. Actually, you know what? I'm going to clear this so that my face doesn't block everything. Near create account gb.a.test.near, and then master count is a.test.near, and our initial balance is 10. Now let's try and run with our postman a get of to the gb.a.test.near. Send. As we can see, values are empty right now, and everything is pretty empty right now. Let's try and set some kind of value. To do this, we're going to do near call. I'm going to rearrange this a little. So we have add message and get message. Near call gb.a.test.near. We're going to call add message. We're going to submit a txt. Gonna have to be in quotes, txt, with a value of my new message. And the account ID signing the transaction is going to be a b.test.near, so someone different than who deployed the account. Let's try and run this and see what happens. Oh, looks like we didn't deploy it yet. Of course. I was wondering why it's not working. Let's clear. Let me just deploy it first. So near deploy wasm file. This is called guest book, and account ID is gb.a.test.near, and I'm going to deploy it. Done deploying. Now let's call that again. Actually, let me call a get first. So get message, so we can see what happens when we didn't call anything yet. We don't have anything yet. Looks like we have a problem. I'm suspecting that the contract didn't compile correctly. Okay, let me solve this issue and then I'll get back. Okay, it looks like I figured it out. I forgot to add this near bindgen code in front of the implement contract trait. And that's what caused the whole code to go sideways. So after that, all I just did was cargo clean, then rust up target add wasm32 unknown, and then just cargo build all target wasm32 unknown release. Okay, so and now if we check the size of this output, it looks a bit more believable. 110.7 kilobytes instead of 86 bytes, which, yeah, 86 bytes looked pretty suspicious. Anyway, now that this is done, let's first clean up our account, because there's usually a problem if you try to deploy a new contract on top of the previous contract. So let's do near delete gb.a.test.near and transfer whatever coins were locked up in that into a.test.near. Yes, confirm. And now I'm going to recreate it. So same thing, near create account, gba.test.near, master account is going to be a.test.near, initial balance will be 10. Let's create this account. And now let's finally deploy our contract to it. So I'm going to do near deploy. So near deploy wasm file is our guest book wasm file, and account ID is going to be gb.a.test.near. Let's deploy it. Good to go. Now let's run our postman again and see if something interesting comes up. Okay, so there's a return. Values are still nothing. Okay. Now, let's actually run a GET request, finally. Okay, I organized my terminal so that it's a little bit easier to see where I'm typing and what I'm typing. Let's call our contract now. So Control R, near call, get messages actually, and account ID. And we got an empty array because we haven't submitted anything to this messages vector yet. Now let's try and run add message. Add, and we are going to push in txt and in this txt we are going to add my new message. Very original, right? Well, let's submit this and let's get messages. So here's encoded my new message. This is in the JSON format. Now let's add another message from, for example, from a different user, from a.test.near. and I'm going to my new A user message, and I'm going to send this. And now let's get it again. And now we have two different messages in this JSON encoded array. My new message and my new A user message. Okay. Now let's see with the Postman what happens when I'm sending a request to get these messages out. So over here we see that we have this state key, which stores some base64 encoded values, and here we have another two keys. Let's take a look what they are decoding as. So I'm going to take a look at this one. This one we already know. This decodes as state. Let's see what this one decodes as. So there's a V and 1, 2, 3, 4, 5, 6, 7, no, like 8 values in total, right? Okay. Let's see the other one. Decode. This is again V with some other value in front of it. Now this deserialization is actually very important if you want to do querying of data from the blockchain from the outside. Problem is that whenever you call the GET request like we do here, using the GET, let me just clear, like as we do here, GET messages, this actually costs near gas price. So you have to pay gas to get this data out. And these GET requests are actually more used for cross-contract communication, more so than for getting it from the outer apps, the applications which are outside the blockchain need to read from the blockchain. Reading from the blockchain works something along the lines of how we do here through the Postman application. This does not cost any near. So you can do, for example, if I only wanted to get this record, I could just take this value right here, copy it, and in the request, I could paste it in the prefix base 64. And if I send this, all that this is going to return to me in the values is a single value with this particular key. This becomes very important when we are going to be working with applications, the front end, right? So in the next tutorial, I'm going to be going over serialization of this values for our guestbook example here. Because if we want to get access to this from using an RPC calls, we have to properly encode this data into the base 64 value. And in order to do this, we need to understand how the serialization works and what all these symbols mean. Like, what is this? What are all these question marks? Why is there 8 of them? You know, we are going to talk about all this in the next tutorial. I'm going to go into fairly fair detail about it, so that when you're developing your front-end applications, when we're going to be doing things, developing front-end applications, there's no confusion why we do things the way we do. Okay, so now our guestbook example is complete. We are getting the values as they should come out, and if I remove this, we are going to be getting the state and then the two values stored in our values section. And all of our methods work as expected. So this is it for this tutorial. It's getting a bit long, and I will see you in the next one where we're talking about serializing and deserializing data. Okay, so I would really appreciate if you like, comment, share, and subscribe, and I will see you guys on the next one. Bye-bye.